You have taken the average of something before, and you know that when you take the average of something, you add up a number of things, whatever it is that you're talking about, and get some total, and then divide it by number of things added. Right? And that always is giving you the average. And so if you'll keep this principle in mind, we can talk about the average value of a function really using the same terms but expressed in terms of calculus. So consider f of x equals x squared, and we'll focus on the interval from 0 to 2. All right, so if you consider the graph of this, you know it's going to look something like this. And when x is 2, the output is 4. And when x is 1, the output is 1. And when x is 1.5, the output would be 2.25. Right? And the question might be, but what is the average value over any part of the interval? And so we're still going to take the total and divide it by the number of incidents. But if you think about it, at every possible x value, there is a y value. Right? So we have all of these y values to add up. And in principle, then, there would be an infinite number of x values and an infinite number of y values, total. Right? But that is what we're doing. Now you do know, or should recognize, that the area between our curve and the x-axis represents the total change. So if we were to integrate x squared from 0 to 2 dx, what we're finding is the total change, or the total per se, on the interval from 0 to 2. And if we were to divide this by 2, we're dividing up the total number of things that we added. Now, it's slightly skewed to say the total number of things. We added up an infinite number of things, and we're dividing by an infinite number of things. And that's really what's happening with the dx here, representing that change being infinitely small. Right? Or likewise, if we were looking at, say, a similar example, but we'll say x cubed to keep it simple, on the interval from 0 to 3, you know that at 0 the function's value is 0, and at 3 the function's value is 27. What's its average value over that interval? We would need its total change, right? So what's the interval from 0 to 3 of x cubed divided by 3? And so the question might be, well, where's the 3 and where's the 2 coming from? And that's just the interval in which you're looking, that we went from 0 to 3, and 3 minus 0 is 3. Or in the first example, we went from 0 to 2, and 2 minus 0 is 2. And so we arrive at this way of thinking about the average value of a function. And the average value of a function is equal to 1 over b minus a. Right? We're dividing by the interval in which we're looking. And that gets multiplied by the integral from a to b of our function. The average value of a function.